Hi everybody. I want to do a quick little review of the unit circle. And I want to make sure that it makes total sense to everybody just how we get a radian. Okay, so as far as like, well, what the heck is a radian? Because I know we did this a long time ago. But we said, okay, if you measure this length of the radius, and if you measured that length, and we did it, I think, in Math 3 with a piece of string, and then we lay that string down over here, so this arc is the same length as the radius. This angle right in here would be 1 radian. Okay, then we filled it all the way in, and what ended up happening is that we found that, well, and I'm not going to be able to do this very pretty because it was a little bit more than 6 radians, and we found that it was 6.28 radians in a circle. Now, hopefully that number looks familiar to you, and you realize that it's 3.14 plus 3.14. So we said, oh, well, instead of writing it that way, why don't we just say it has 2 pi radians in a circle? Now, when we're in calculus, we're almost, and I say almost, never going to use degrees. Radians, we're going to see that they're a lot more useful when it comes to calculus. And I'm going to learn to say a lot less often, but I'm working on it. Okay, so I want you to think about if a circle has 2 pi radians. So I start here, and I go all the way around the circle, and I'm at 2 pi radians. Okay, well, if it's 2 pi all the way around the circle, then halfway around the circle would be pi. Okay, well, what if I want to go 1/4 of the way around the circle? I want to go to here. Well, I need to take half of pi. Well, half of pi is just pi over 2. Okay, so you should always be able to quickly figure out in your head what 90 degrees is in radians, pi over 2. So let's just count by pi over 2. Okay, so I'm at 0. I've got 1 pi over 2, 2 pi over 2, which reduces to pi, 3 pi over 2, and 4 pi over 2, which reduces to 2 pi. Okay, so I always start with those right there. Okay, the next one that's really easy for me is I think of, well, what if I have a 45-degree angle? Half of 90, right? 45 degree? Well, half of 90, and 90 is now pi over 2, so I want to think half of pi over 2, and I just multiply straight across. That is pi over 4. So there we go. That's how I can figure that out. So now I'm going to count by 45 degree or pi over 4. So here's pi over 4, 2 pi over 4, which reduces that, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay, so that's all I'm thinking about, counting that way. Okay, now let's look at the ones that are a little bit more confusing, the 30 and the 60 degree. And I just really look at the 30-degree angle. Okay, so remember that this is 90 degrees. So I do kind of always have degrees as a reference. And that's a 30-degree angle. Well, 30 is 1/3 of 90. Well, if 90 is pi over 2, then I'm going to say 1/3 of pi over 2 is pi over 6. So that's how I can figure out a 30-degree angle. Okay, so let's just count in pi over 6. Okay, so from here to here is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, and I can put that in. From here to here is another one, so 10 pi over 6, one more, 11 pi over 6, and one more, 12 pi over 6. Now you're thinking, wait a second, what are you doing there? You didn't reduce them. And I didn't reduce them because I wanted you to see how we're just counting by 30 degrees. So I could come back over here, let me get a different color pen, and I could say, well, that is just pi over 3. That is 2 pi over 3. That, oops, that should have been a 6 right there, is 4 pi over 3. And that is 5 pi over 3. Okay, so I want you to make sure that you're able to go around a unit circle and figure out all of those. I don't want you to go, I'm going to make a conversion from 30 degrees into radians. I've seen people do that. Terrible. Okay, make sure that this makes sense to you. All right, see you guys later.